All right, here's 4.9, Systems of Equations Practice. Okay, so there's three different methods that we know how to graph, or not graph. We know how to solve a system through graphing by hand or with technology, through substitution, and through elimination. Okay, so I don't care which version you use, it works for any of them. For the first ones, I'm going to do according to which way it says to. But again, you don't have to. You can use technology to help you out with this, or you can do it by hand too. Okay? So these first ones are going to have us graph. So I'm going to graph by hand because they're in slope-intercept form. Again, you could use the graphing calculator to help you out with this. So if I look at number 1, I've got -4 for my y-intercept and a slope of -6. So I'd go down 6 into the one right, or up 6 into the left one. Okay, there's my first one. Then I graph my second one, +4, and down 6 to the right one. So what I should notice here, that they have the same slope, so they're actually parallel lines, which when they're parallel lines, it means they're never going to intersect, so no solution. Okay, number 2, y equals 2. So y value of 2, horizontal line there. Okay, then y equals 3x minus 1, start at -1, go up 3 to the right 1, up 3. So I can see these ones intersect. So there's one solution, and the place they intersect is at 1, 2. Okay, number 3. +2, slope of -5, down 5, to the right 1. Okay, then slope, start at -2, slope of -1, down 1 to the right 1. I can see right there, one solution, and that is at 1, -3, because that's where they intersect. Okay, number 4, -2, down 1 to the right 1, or up 1 and to the left 1. That was a horrible drawing. Okay, then up 3, slope of 4, so up 4 to the right 1, or down 4 to the left 1, which I can see exactly where they intersect, and it's at -1, -1. Okay, so graphing, that's how we can do it. And had you graphed the same line, so it was the same line, remember that would be infinite solutions. Now, the next 4 are set up for substitution. So that's the method I'll use. So, notice they're both equal to y, so basically I can set them equal to each other to find x. And then we solve. Subtract 23, which would give us -32, add 4x, which would give us 8x, divide by 8, we get -4 for x. Then we plug in a -4 into one of these. So y equals -4 times -4 minus 9, which would give us a +16 minus 9, which would give us 7. So y equals 7. So one solution, and it's 4, 7. It's the point where they intersect. Okay, number 6, same idea. They're both equal to y, so I just set them equal to each other. Add 4x to both sides. We get 7x, subtract 4. We get 0, divide by 7. 0 equals x. So if I put a 0 in for x, 3 times 0 is 0, plus 4, we get y equals 4. So one solution, and it's at 0, 4. Okay, number 7. Y equals -1, so replace y with the -1 and solve for x. 7x plus 1 equals -6, plus 1. So subtract 1. 7x equals -7. we get x equals negative 1. Then y also equals negative 1, so negative 1, negative 1. One solution. Number 8, we've got this equal to y, so we take that whole thing and plug it in for y. So I get 24x plus 3 times, instead of y, negative 8x plus 3, and equals 9. So 24x plus a negative 24x plus 9 equals 9. So that would give me no x's. Subtract 9, I'd get 0 equals 0. Okay, which is true. And remember, when we have it equal the same thing, that's as if we had the same line, overlapping itself, which means there's infinite answers or infinite solutions here. So when you get rid of your variables and it's still true, you get infinite solutions. Okay, and that's substitution. All right, oops. So now we've got a few set up for elimination. Okay. So they're all lined up, negative 10 and positive 10. So I'm going to add those. So 3 plus negative 2 is just 1x. Negative 10 plus positive 10 is a 0y. Negative 18 plus 22 equals a positive 4. So x equals 4. Take one of these and plug in x equals 4 and solve for y. So we'd get negative 8 plus 10y equals 22. Add 8. 10y equals 30. Divide by 10. And y equals 3. So one solution at the point 4, 3 is where they intersect. Again, you can use any method you want to. These ones are just kind of set up to be used a certain way, so it's kind of what I'm showing you. Okay, number 10. Positive 3 and a negative 3, so we're going to add. That would give us 0x. Negative 2y, positive 2y would give us a 0y. Positive 20 plus a negative 20 would be a 0. So we have 0 equals 0. Again, this is infinite solutions, because we got rid of our variables, but it's true. Okay, number 11. Negative 5, positive 5, so we're going to add again. We get 1x plus 0y equals negative 10. So x equals negative 10. So negative 10 minus 5y equals negative 30. So positive 10. Subtract 10. Divide by negative 5. We get y equals positive 8. So solution at negative 10, positive 8. That's where they intersect. All right. Number 12. Again, we would add negative x and positive x would be 0x. Negative 8 and 3 would be 5y. 2 and negative 2 would be 0. 5y equals 0. Divide by 5. Y would equal 0. So 0 plus 3. Y equals 0. So x plus 3 times 0 equals negative 2. That's 0. So x equals negative 2. So negative 2, 0 is where they intersect. All right. Now, looking at these ones, okay, they're kind of set up to be able to use graphing. Some of these are set up that elimination is easier or not, or sometimes substitution is easier. It just kind of depends on the setup of the problem. Okay, so I'll try to kind of use the best one, but maybe at least on one of them I'll show you that every method would still give you the same result. Okay, so these ones that are set up as slope-intercept probably going to be easier to graph them, right? So down 1 to the right 3, or up 1 to the left 3. Then positive 1, up 1 to the right 3, and I can see exactly that they're going to intersect at 3, not 2, 3, 3, 2. Okay, so positive 1 down 4 to the right 1, or up 4 to the left 1. That was a horrible line. negative 2, down 1 to the right 1. Again, I can see exactly where they're going to intersect, which is at 1, negative 3. Okay, number 15. Positive 2, down 3 to the right 1. Up 3 to the left 1. Then negative 3, up 2 to the right 1. You can see intersects at 1, negative 1. Okay. Now, like I said, we don't have to use that. We could do something else, like this one. They're both equal to y, so I could use substitution, set them equal to each other. So I could subtract 5/3 x. That would become 0. That would become 0. I get negative 2 equals 4. If I added 2, I get 0 equals 6. That's not true. So these would be parallel lines, so no solution. Okay? Alright. Now, most of these, if you'll notice, they're kind of lined up pretty easily. Kind of set up more for, look at that. Same exact line, you know exactly what that's going to be. You don't have to do anything. That's infinite solutions. Okay, if you graph it, it's the same exact line because it looks exactly the same. So those ones are pretty easy to spot. Okay. So using technology, either our graphing calculators or if we're at home and we don't have access to them, Desmos, which is an app or as a website, is a great tool to use. And we can see for number 18, easy to graph and easy to see, one solution at 0, 4. Okay, or like number 19. Okay, we graph these two. We can see it, one solution up 5, negative 3. Or number 20, which this one we can see there's parallel lines, so parallel lines mean there's no solution. Okay. Or again, we don't have to, we can do them by hand. Okay. Notice I can't get those to match up, but 3 I could double, right? So if I double the top equation, I'd get negative 8x minus 6y equals 36. Then I could add them, giving me 4x plus 0y equals 24. Negative 24 plus 36 be 12. So 4x equals 12. Divide by 4. We get x equals 3. Then plug it in for x. So negative 4 times 3 minus 3y equals 18. So negative 12 minus 3y equals 18. Add 12. Negative 3y equals 30. Divide by negative 3. And y would equal negative 10. So we'd get one solution at 3, negative 10. Which if we graph, we can see that as well. Okay, as we can see right there. Okay, looking at number 22. Same idea. Okay, I could double 6 or even double 3 or triple 3. Okay, either one. So probably doubling is easier. So negative 12x minus 6y equals 24. Then add them, 0x, negative 15y equals 30. So negative 15y equals 30, divide by negative 15, and y would equal negative 2. So I get 12x minus 9 times negative 2 equals 6. 12x minus 18 equals 6. Add, that would be a positive 18, so subtract 18 because negative times a negative is a positive. 12x equals negative 12, divide by 12, and x would equal negative 1, so negative 1, negative 2 for my solution. Okay, multiple ways I can do that. Or like number 23, again, we could graph it. But when I graph it, it looks like one line. So if I were to solve it, I could double the top, and what do I get? 14x plus 12y equals 28. So we'd subtract 0x, 12 minus 12, 0y, 28 minus 28, 0. So 0 minus 0 is 0. So they overlap, which means there's infinite solutions. Okay, so a lot of different ways that we can deal with these. We could even do substitution. Okay, so I've got x minus 4y equals negative 22. Add 4y to both sides. Get x equals negative 22 plus 4y. So in this equation, I can replace the x with negative 22 plus 4y minus 8y equals 26. We get negative 198 when we distribute, plus 36y minus 8y equals 26. So add 198. So 198 plus 26 is 224. Then 36 minus 8y would be what? 24y? Nope. 28y. So divide by 28. We get y equals 8. Now we know what y is. We go 4 times 8, which is 32, plus negative 22, and that's going to equal x. So x equals 10. So one solution at 10, 8. Okay? Now, if we're given a story problem like these last few, we just treat it the same way. So Huang and Jessica each improved their yards by planting hostas and ivy. They bought their supplies from the same store. Huang spent 66 on 4 hostas and 10 pots of ivy. Jessica spent 78 on 7 hostas and 10 pots of ivy. What is the cost of one each? Okay, so we could think about this visually and say, okay, we've got 4 of the one type of plant, right, for Huang, plus 10 of ivy, so those are the ivy, and that was 66. And then Jessica had 7 and 10. And that was 78. So, kind of like that elimination, we can think, okay, they have the same amount of ivy, right? So the ivy is not going to make the difference. What's going to make the difference is the 10, or the 3 hostas here. Okay? So if I subtracted, right, we'd end up with 3, negative 3, because the top was 4 minus 7. Negative 3 of the hostas plus 0 ivy, because 10 and 10, would equal 66 minus 78, which is negative 12. Or had we done it backwards, we would have had positive 3h equals positive 12, same thing. Trying to kind of combine the two. Divide by negative 3. We get h equals positive 4. So $4 for the hostas, which if we know that they're $4, I know those 4 would be $16. So 66 minus 16 would give us 50. Divided by 10 means the ivy were $5 each. Okay, so that's one way you can do it, is drawing pictures. Okay, and then just kind of solving it that way. Another way would be to create an equation. So the school that Wilbur goes to is selling tickets to a spring musical. On the first day of ticket sales, the school sold 7 senior citizen tickets and 1 student ticket for a total of 5. So we have 7. Let's go C for senior citizen, plus 1 student, S was 50. The school took in 86 on the second day by selling 13 senior citizens and 1 student ticket. Okay, what is the price? So again, we've got the 1, so I can subtract. 7 minus 13 would be negative 6, plus 0 students, and then 50 minus 86 would be negative 36. So negative 6c equals negative 36. Divide by negative 6, and we get c equals positive 6, so $6 for a senior citizen, which if a senior citizen is $6, 7 times 6 would be 42, plus 1s equals 50. Subtract by 42, and we'd get, for a student, it was $8. Okay. Numbers are 27. The State Fair is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B, lovely names, both planned trips there. The senior class at High School A rented and filled 7 vans and 11 buses with 537 students. High School B rented and filled 7 vans and 5 buses with 309 students. Each van and each bus carried the same number of students. Find the number of students in each van and each bus. So again, 7 vans, 11 buses for 537 students. Okay, High School B, 7 vans and 5 buses with 309 students. Okay, now could I graph this one? Yeah, you betcha I could graph it. But when I graph it, I would need to change the V's to X's and the B's to Y. Okay, so it'd be 7X plus 11Y equals 537, and 7X plus 5Y equals 309. When I do that, I plot my 2 graphs, and I see the intersection point is 17 and 38. So 17 would be per van, and 38 would be for a bus. Wow, those are big vans, right? That's crazy. And why you'd use all those vans and not buses, I don't know. That's just kind of weird. All right, let's take a look at the last problem now. So, Gabriella and Wilbur are selling cookie dough for a school fundraiser. Customers can buy packages of white chocolate chip cookie dough and packages of oatmeal cookie dough. Gabriella sold 4 packages of white chocolate chip and 4 packages of oatmeal cookie dough for a total of 128. Wilbur sold 6 packages of white chocolate chip and 4 packages of oatmeal cookie dough for a total of 154. Find the cost of each 1 package of white chocolate chip cookie dough and 1 package of oatmeal cookie dough. Now, I could also use substitution. So say I subtracted 4 of oatmeal, I'd have 4W equals 128 minus 4 oatmeal, divide by 4. I'd get W equals 32 minus oatmeal. So then I'd go 6 times 32 minus an oatmeal. Shouldn't have used oatmeal because that looks horrible. Looks like zeros, doesn't it? Okay, and I would get 192 minus 6O plus 4O equals 154. 6O and 4O, negative 6O would be negative 2O. Subtract 192. We get negative 38, so divide by negative 2. And the oatmeal package, the cost is going to be 19. Ooh, that's expensive, $19. If that's $19, I go 32 minus 19, right? Because I could put 19 right there. For the white chocolate chip, that would be $13. Okay? Again, I could graph it or do anything like that. But there we go, guys.